Hello everyone, my name is Stephen Hassambelli and today I'll be doing project 2 of Fundamentals of Aerodynamics, and today's project will be in XFLR5 where we'll be analyzing the NACA 4412 airfoil, and we'll also be analyzing its application in different wing configurations. We start off by clicking on modules and going on XFoil direct analysis. We'll be importing our airfoil by going into design, NACA foils, and we'll be typing in 4412. And I also like to include a couple more panels. There we go. Once we do that, we'll be doing a batch analysis of Reynolds numbers. And right up here, since I've already done this project before, it auto-populates my previous values, which go from a Reynolds number of 800,000 all the way up to 5 million. Our range of interest goes from 110, 1,100,000 Reynolds all the way up to 4 million because our chord lengths will be 2 meters and down to 0.6 meters. Once we do that, we make sure that we specify alpha or alpha range from -5 all the way up to 20. And the increment, we'll just keep it at 1 for now, and we'll just hit analyze. There we go. We can close this panel, and right up here we can see all of our CL alpha, CD alpha, CLCD alpha, and CLCD graphs for all the different Reynolds numbers. And right up here, we can also take a look at our Reynolds numbers of interest, 1,100,000 and also 4 million. And these will be the graphs, which we can then export just by simply hovering over the graph itself, going to current graph and export graph. And we can also export it as a CSV file for easier import into Excel. Next step, we'll be going to modules and doing the wing part of this project. We start by defining a new plane, and we're gonna type in AR6 rectangular, and we're just gonna be analyzing the wing, so we can just simply deactivate elevator and fin and click on save. Next will be what was it? Current plane, and then we go into edit wing. And the shortcut for that, as you guys saw, was Control W, which is what I primarily use. Now our chord length will be 2 meters all the way through. We can set the offset to 0, and our wingspan will be 0, and it will be mirrored, so technically the wingspan, as we can see, will be 12 meters. Our aspect ratio will be 6, which is what we're looking for. We're going to make sure to click here and select the airfoils, and here's going to be our first wing. Hit on save, and there we go. And now we're just going to rinse and repeat the process for all the other 3 wings, which will be AR6 tapered. There we go. We can Control W, and our tip chord length will be 0.6, which will give us a taper ratio of 0.3 as per project statement. And our wingspan, I believe, should be 3.9, which will give us an aspect ratio of 6. And also what I like to add is an offset of 0.7. We'll click here, and here we can see that from the top it's going to be right about symmetric as well. There we go. And we can hit save. Go. Control W. It's going to be our aspect ratio 12, as you guys can see from the numbers all the way up here. Taper ratio 1, no taper. Click on save, and last wing will be here 12 taper. Go. 2.6, 7. This will be 6.8. There we go. Same thing here. Nice and symmetric. We can see that. Oh, what happened up here? 7.8. There we go. Now we have an aspect ratio of 12, taper ratio of 0.3, and here's our wingspan as well. We can just hit save, and there we go. From here on out, we're gonna do all of our analysis, and let's start from this one. I'm just gonna click on analysis, define analysis, keep it at fixed speed, and our speed will be 30 meters per second. Just hit save, and then we can, let me move this from -5 to 20, increments of 1, analyze, there we go. And we can take a look at our graphs right away. Here's all the different alphas. There we go. Now we're just gonna be redoing the same for all the other wings. Oh, and let's take a look at these graphs as well. Here's our CL alpha, CD alpha, CLCD, and CLCD alpha. There we go. And just in case you guys don't get these graphs here, meaning CL versus alpha, you can just hover over the graphs, click on G, and that will allow you to change all of the axes. There we go. We're just going to analyze the rest of the wings. 30 meters per second, fixed speed, analyze. Okay, let's check. There we go. Here's our issue. We hadn't selected the foil for this one. And now we can analyze this as well. There we go. And some alphas will not converge. That's normal. Just don't worry about it and continue with the data that you did receive. Let's do this one now. 30 meters per second. Here's our third one. And lastly, there we go. Same thing here. This time only alpha 20 did not converge. And we have all of our graphs here. We can again, and to look at these values, these will also be in terms of wingspan as well. To look at these values, just make sure you select one of these values. Like for the AR6 rectangular wing, if we want to take a look at the 5 alpha, this is what it would be. Just make sure you select it. For exporting values, same thing again. You just right click, you go onto current graph and export graph, and I'll export it again in CSV. Same thing here, export graph again, and you will have to do it for every graph. So you're going to have to hover over this one, export graph, same thing for all the other ones as well. And you're going to have to do it for every wing again. This one, for example. Yep. There we go. Same thing here, export all of the graphs individually. And up here, we can also see the wing itself, and we can see all of our lifts, induced drags, downwash, and everything. And if we click again on the different alphas, the wing will animate and move to the selected alpha value. And just as a quick thing as well, we can also decide to animate it too. And we can see the lift distribution. We can see the induced drag as well, and also the downwash as well. There we go. And that'll be it for the project. After that, you're just gonna post-process all of the data in Excel, and you can build your own graphs and plot them and compare all of the results.